welcome back from your break. I guess pretty sure this is on, but again, in the other room, if there are any issues with the audio, please let me know. Or in this room, if at any point you can't hear me, wave around, let me know. Okay, so this next section will be on pipelining, and will be actually let me fix this view for. So in this module on pipelining, we'll be primarily focused on the tools that we use for pipelining at the Broad Institute. There are a lot of other tools and solutions for pipelining out there. Some of what I talk about will be kind of general concepts, but some of it is talking about the specific tools that we use at the Broad Institute, because we think they're good tools, and they're open source, so you guys can also all use them, and that's where we have our expertise as well. Okay, so what is pipelining? Pipelining is when you have multiple different tools that you want to run on your data in sequence. And so instead of running each tool manually and independently, we want to string them together in an automated way to create a data pipeline. So we just talked about the data pre-processing pipeline, and it's shown again on the screen, where we take our input data, the unmapped band file, and then we want to run 3 different tools on it. BWA mem for alignment, mark duplicates, and then base quality score recalibration. So you could run BWA mem, wait for that to finish. You go grab a cup of coffee, you come back and you check and see if it's done. If it's done, then you launch mark duplicates, you wait around some more before you launch BQSR. So that's something you could do. But that tends to take longer because maybe you were getting your coffee when the tool finished, and so you didn't see, and so it took an extra 10 minutes for you to start the next tool. That could also be kind of error prone. So you have now 3 different opportunities to supply the wrong input file, for example, because you're launching 3 different tools. And you're now spending a lot of your time monitoring these tools and launching the next step in the process. So instead of having to manually launch each of these tools, what we want to do is automate that process and create a pipeline. So we want to script a workflow that will launch the alignment, and then when alignment is finished, it will launch mark duplicates automatically. When that's finished, it will automatically launch BQSR. So you just have to start one pipeline instead of 3 independent tools. So that will save you time, it will make it easier on you. It will also reduce the probability of errors. You only have to set up one pipeline. And it also allows that pipeline to be more reproducible. You can share the whole pipeline with another person in your group, in another group. They can run it and get the exact same output. And it will also increase auditability. So you can record very precisely exactly what process was executed on your data. Go back and check the whole pipeline, what happened at each step. So basically, it saves time, reduces errors, and makes things a little bit easier to just automate those pipelines. So that's what we'll be talking about today. And there's a lot of different ways to do that. I won't be able to see the other room, but can I get a show of hands in this room for anyone who's worked with either writing or running pipelines on data? Okay. Some hesitant hands in here, a few people. Would anyone like to share what platform or how they actually run pipelines?
We are using Bash shell script.
Okay.
Yeah.
Yeah. Okay. Yeah. So that's a really common way to run pipelines is using Bash. So we actually have that up on our slide, the picture of the terminal. You can write a shell script that will call each of your tools. You can run that on your laptop or submit it in a high performance computing environment. Yeah, so that's a really common solution. We also have a few other common pipelining platforms on this slide. For example, Galaxy, anyone uses that here. But actually, at the Broad, we decided that we wanted a platform that was a little bit more, that encompasses all of the features that we want all in one place and a little bit more tailored to doing bioinformatics in the cloud. So we have the Terra platform. And you've all signed up for Terra, made an account, and we mentioned that that's what we'll be using for a lot of our demonstrations, because then we can all be using the exact same environment. We might have a different version of Python installed on your laptop. That doesn't matter because we can control the environment, etc. But you don't have to use Terra to run our GATK tools or pipelines. That's just kind of one option. And part of what I'll talk about today is, some of the benefits of using Terra. It is a good option, but it's not the only option. And for kind of the rest of this presentation, I'll build up from how do we code the pipelines to how do those pipelines actually get executed, and then how Terra kind of brings all of those pieces together in a user-friendly platform. So we'll start with the code. So we use workflow description language to script our pipelines. It's abbreviated WDL, so we call it WDL, just to keep it easy to say. And this slide shows an example of how a WDL is structured. So on the right, we have a workflow, and it takes in some inputs, and then it calls task A on those inputs, and then it calls task B on the outputs of task A. So we've now strung together those two tasks. We'll first run task A. Once that is complete, we'll pass that data onto task B. And then we can zoom in on task A on the left. What does that look like? Again, it takes in some inputs, and then we have a command section. So this might be a particular GATK tool or a bash script with multiple GATK tools, or you write your own Python script. You want to run that inside of the task. So we're doing some process on the data in the command section. Then we have the runtime section where we can specify a Docker image. I'll talk about that on the next slide. And then we have an output. So what file are we producing from task A? And in this case, in our workflow, we'll then pass that output onto task B. So it's designed to be fairly readable and accessible. Even if you don't have a background in programming, you should be able to look at this and kind of understand what's going on. So I mentioned that for each task, you can specify a Docker image. And a Docker is a type of container. There are other types of containers out there, for example, Singularity, but we most often use Docker images. And what is a container? It contains all of the software and all of the dependencies of that software that you need in order to run a particular task. So many of you in this room have probably encountered the difficulty of you're trying to run a particular bioinformatics tool, you download the tool, you go to your command line, try to run it, and it's like, oh, it can't run because it needs some other dependency. So then you have to go and install that. And then maybe that has some other dependency. And now you're spending hours just trying to install everything that you need for this tool, and you haven't even gotten to test it out yet. So that's kind of a headache. So the benefit of using a container is that everything is already installed in that environment. It's an environment that is ready to use every time that you want to run your tool. It's also an environment that is reproducible and shareable with others. So your colleague can use the same Docker container and have the exact same versions of the software and get the same results as you do. So it's helpful for reproducibility and sharing, as well as just making it easier for you to install things. Okay. And I want to also mention that there is a Docker for GATK that we make available publicly. So that contains the GATK software and all of the tools, as well as all of the dependencies. So you're welcome to use that. And we will use that Docker image in several of our demonstrations throughout the workshop. Okay. So we talked about what the code looks like to script these pipelines. And once we have that, how do those pipelines get executed? So at the Broad Institute, we use the Cromwell execution engine, and that takes in a workflow, either in WDL or in another workflow description language called Common Workflow Language, and it will understand and interpret that workflow script and know that, okay, we need to execute task A before we can start task B, because task B uses the outputs of task A. So it will do all of that interpretation. It will handle figuring out which inputs go to which task. It will spin up a virtual environment with the Docker image that you've specified to run that task, execute the task, get the outputs, and pass them to the next task. So it'll kind of handle all of the file wrangling and the execution of the tools. And Cromwell is compatible with several different backends, so you can run it on several different in several different environments. So you can run it locally on your laptop, you can run it on a high-performance compute system, and you can also run it on several different cloud platforms. And most commonly at the Broad Institute, we use Cromwell on the Google Cloud platform. But this interoperability means that you can run a pipeline on several different backends and get the exact same output, because the WDL is compatible with multiple different backends, and Cromwell is compatible with multiple different backends, and your Docker images make sure that the environment is exactly the same on each of those backends. So I will note, though, that if you're writing a new pipeline, you do have to make sure that the actual code that you're writing is also compatible with different backends. So it's possible with these platforms to have this kind of interoperability, but it has to be present at every step of the pipelining process in order for it to work. Okay, so I mentioned that at the Broad Institute, we most commonly use the Google Cloud platform, and I want to talk a little bit about why we made that decision and some of the benefits of that. So in a traditional model that we used for many years, when there is data that needs to be shared, it's stored in some sort of central repository, but then when you want to use the data, you have to download it and make a copy on your local machine or on your institution's computing environment. You have to have a copy before you can actually use the data. And that also means that each institution has to have its own computing infrastructure. And the computing that you can do as a user is limited by the storage and the computing performance that is available at your institution. And also, each institution has to implement its own security practices. So those might not be consistent at all of the institutions that are using that original data. In contrast, in the cloud, there's again one central repository for the data, but you don't have to download it in order to use that data. You can actually use it directly in the cloud. And that happens by also performing your computing inside the cloud, which means that you're no longer relying on the infrastructure that's present at your institution. You can take advantage of the storage and computing resources that are available in the cloud. And that also allows for elastic compute and storage needs. And what I mean by that is that you can scale up to a very large amount of compute on a certain day, and also scale down to use very little computing the next day. And you're not maintaining the infrastructure for a huge amount of compute all the time when you're not using it all of the time. And finally, there's one centralized security implementation that exists in the cloud. So whoever is responsible for maintaining the data can oversee all of the security and be sure that it's consistent for all users. So just as an illustration of that elastic computing capability of the cloud that I was mentioning, these graphs show the number of genomes that are processed by the genomics platform at the Broad Institute on a given day on the left, and then the number of exomes, again, processed by the genomics platform on the right. So you can see that on some days, GP is processing over 600 genomes in a day, but on other days, less than 100. And with the before we moved to the cloud, that meant that we would have to maintain the computing infrastructure to be able to process over 600 genomes all of the time, even though we're not using it all of the time. But with the cloud, we can process over 600 genomes on a day if we need to, but we don't have to pay for that compute on the days when we're not doing that much processing. It also means that if we do need to scale up and do a ton of genome processing in one day, that doesn't compete for resources with other projects. It's not going to push those to the back of the queue. We can just pay more for more resources on that day. So this is kind of one visualization of how these pieces fit together. So you have a set of tools that you want to run, and then you can write you can script your pipeline in WDL, you can pass that to the Cromwell execution engine to execute that pipeline in it. And that can be done locally. So for example, we do a lot of our testing and development locally on small test data. And then that can also be run in the cloud. So that's where we run things at scale in production. So talking about specifically GATK, there are a number of ways that you can run GATK. You can run it from your command line. You can even access data that's living in Google Cloud directly from the command line without downloading it, because GATK is able to stream directly from a Google Cloud resource. You can also use GATK4 with Spark. Again, from your command line, it's able to use Spark for parallelization. You can use Cromwell to execute pipelines that contain GATK tools, and we also publish WDLs for those pipelines. And then you can also use Terra, which provides an easy, accessible user interface for all of that. So let's talk a little bit more about Terra. So Terra is a web application that is kind of supposed to be a full service platform for doing cloud computing. And right now it operates in Google Cloud, but there's a whole team that is hard at work at also getting it to operate in Azure, which is Microsoft's cloud. And it is free. You can access Terra for free. And all you have to pay for is the actual cloud computing costs that are charged by the Google Cloud Platform, or in the future by Azure. And I said it was kind of a full service platform. So what can you do with Terra? You can manage data storage in the cloud. So you can use Terra as an interface to store your data, or to share your data, or to access data that other people have put into Terra. You can use it to run pipelines. Under the hood, Terra will use Cromwell as the execution engine, but it provides a nice graphical user interface to interact with Cromwell and run your pipelines. And you can also use Terra for interactive analysis. So we'll be using notebooks in Terra for a lot of our demonstrations. So you'll get to try that out for yourself. Okay, so just to kind of sum it up, you want to run a series of tools on your data. For example, the BWA mem, our duplicates, BQSR. So you can script a pipeline. We'll run all of those tools sequence with WDL. So you can run the whole data pre-processing pipeline. You can use containers such as Docker images to create easily reproducible environments for those tools to run in. You can use Cromwell to execute those pipelines on whichever backend you prefer. And if you're working in the cloud, then you can use Terra as a platform to interact with all of those aspects of data storage pipelines and analysis in the cloud. And actually, the next session, I'll hand it over to Anton to walk you through Terra so you get to see how it all works. Any questions before I hand it over to Anton? I'll give it a second in case there's one from the other room. All right.
Thank you. So I need to get on. Go to, yeah.
Oh, this here, it's not handle and it's just a lot.
And I'm signed on as just Eric, thanks. So this part is technically not a hands-on walkthrough. I will say that everyone should feel free to follow along with me on their own laptops if they want, because you can click around on the different buttons and ask me about what the buttons do. I don't promise I know what every single button does. But that's what we're going to do in this session. I'm going to give everybody a tour of the Terra platform. I wanted to start by saying that this is technically a GATK workshop. Am I talking too loud? Say a little farther away. Oh, slower. Slower. Got it. This doesn't mean slower. This means shorter. So I wanted to start by saying that this is technically a GATK workshop, and the vast majority of the content that you'll be listening to is how the GATK tools work and how you should use them. But at the same time, this is also going to be a workshop about using the Terra platform. That's my main job, is to teach people how to use the Terra platform. So I think most people here are going to be very familiar with running tools like these on your command line. And that's not what we're going to do for the most part. And you're very welcome to take everything that you learned today and keep doing it exactly how you've been doing it on your terminals. But we hope that you will enjoy this demonstration enough to maybe use Terra for your development needs, for sharing your analyses with collaborators, and for publication. It's a great platform for all of these things. It's a way to publish your data. It's a way to do data delivery if you want to do data delivery, because you just give other people access to workspaces that you create, and then you upload your data to those workspaces, or have those workspaces automatically grab the data in some fashion. So it's really great for all of those purposes. The elasticity of the computation makes it very useful as a development environment. So feel free to ask me any question that comes up about how to use Terra, and I will hopefully be able to answer. So I'm going to have to stand over here because I need to click around as we're doing that. So the very first thing is to go to app.terra.bio. So I'll start by saying that the website, the URL for the app itself is app.terra.bio. We also have a lot of great documentation at support.terra.bio. And if you go to just terra.bio, that's actually the marketing website. So don't get confused. You go to terra.bio and it's not this. That's because that's the marketing website before this. So if you want to go to the Terra application, you go to app.terra.bio, and then you go ahead and sign in with your Google credentials. And by the way, if you haven't yet successfully been added to a billing project, we can take care of that definitely today. But make sure that when you tell us your email that you want to be added to the billing project, you use the same one that you used to register for Terra. So here I am, not really me, but you know, just as good. We'll start by just describing everything that's in this main menu. So we call this the hamburger menu. So if you click on the hamburger menu icon, then you will see all of these options. Under your name, you will find your profile. In your profile, it can be very useful to know that this is where you are able to log into various external identities in case you need to authenticate into controlled access data sets. Terra is very useful for that. That's one of its great superpowers is, as Emma said, Terra makes use of the cloud by not forcing you to copy all of your data constantly. All you have to do is point at that data. And if it's controlled access data, Terra has ways of granting itself that access. This is one of the places where you would do that. You can also go here to change your different notification settings. So these notification settings will send emails to you to let you know that your workflows have completed or have failed or something like that. There's a lot of different notifications on them. In addition to that, you can find your groups, which I think everyone here will not have any groups. This is an added security feature. So we won't be using managed groups in this demonstration or authorization domains. Authorization domains and managed groups are a similar concept. They're not exactly the same, but they're basically like a security badge. And you can add a security clearance to any workspace that you create so that only people who are part of that managed group are able to clone that workspace. We're not going to be doing anything like that because we're not working with anything particularly sensitive, but Terra is made so that you can work with lots of sensitive data, and this is one of the big features for helping with that. You can make these managed access. Here, of course, you can find your billing information. You can also click over here to see all of your cloud environments. These are your interactive analyses cloud environments. You will understand exactly what I mean by that by the end of this workshop for certain, hopefully by the end of today. It takes a little bit of time. Sometimes some of these pages take a long time to load, especially if you have been using Terra for a long time and you have lots of stuff. So in this case, I'm not sure why it took so long to load, but here in this case, you can see that Eric has one cloud environment that is currently in a paused state, and it has a persistent disk storage attached to it. So that's what we can find here. So I'm gonna skip over going to the workspaces tab for a moment because that's one of those ones that takes a long time to load because I have so many workspaces. So I'll come back to that in a moment. But in the workspaces tab is where you can access all of your old workspaces. You can also find all public and featured workspaces through the workspaces tab. But in addition to that, you can go to the library to find featured workspaces. So Terra has a very rich library of both data and tools. So if I were to go to the data sets section of the library, I could see a subset of the data that you could import to your workspaces from these various consortia. Some of these, so if I were to click Browse Data or Explore any of these consortia, some of them will take me to a page set up by that consortium, and some of them will take me to a data explorer that's integrated into Terra. And so in here, I could save this whole cohort, or I could select, let's say, I'm only interested in studying people who have these particular types of samples, and maybe I'm only interested in a very specific population. So there, I whittled it down to some 700 participants, and now I could save that cohort, and I would give it a name, and then I would send it to a workspace. And you'll see what that looks like later on. So there's lots of ways to grab data. And again, you're not actually moving any data. The only thing you're moving is metadata. So, so that's what you can find in the data sets part of the library. Under code and workflows, you can find specific workflows. So these are probably the most relevant to this particular workshop. These are very popular GATK workflows. And so I could click on one of these and I could also send it to a workspace of mine, or I can always go into the doc store or the Bro methods repo and find some other tool and also import it into my workflow. You have lots and lots of ways to import both workflows and data into your workspaces. If, however, you much rather just grab a more or less complete example workspace, we have a variety of featured workspaces that have very rich dashboards to explain everything that's going on in those workspaces. Those workspaces will generally have metadata. They'll have either notebooks for running analyses, or they'll have different workflows. I'll go through all of those tabs in more detail in just a moment. This is just to kind of acclimate everyone to how much featured offerings we have. Now over here on the left, you can see a bunch of filters for the different topic areas that all of these workspaces correspond to. So we have some general getting started topics, but also more specific things like different analysis tools, different experimental strategies, different consortia that will have featured workspaces to help you learn how to work with the data from those consortia, and basically all sorts of different options to find lots and lots of featured materials. And you can just look into those workspaces, and then if you have access to a billing project, which everyone here now should, and if you don't yet, by the end of the day you will, you can make a clone for yourself of the workspace, and then you get your own dedicated storage to go with that workspace, and you can spin up all of the computational resources that you can afford on that workspace. So that's what we'll do in a moment, just after I finish showing everybody all of the things that that we work hard to make sure are available for everyone. So in addition to all of that, we have lots and lots of ways to support Terra users. We have some quick start guides that basically are tutorials that are very similar to what we'll be doing here, but they also go into a little bit more detail with respect to how you run workflows, how you run more complicated workflows, how you configure your workflows. So if you want to learn how to do that, you should use the quick start guides. There are a lot of very deep tutorials, both about the basics of running workflows and about more specific use cases. As I mentioned, we have a very rich support site. So if you click on Terra Support Home, that I believe takes you to support.terra.bio. We have lots and lots of articles on there. And if there's anything on there that you don't find, please let us know because we'll write it. We have lots of video walkthroughs. We have a nice request to feature. So if you find yourself, for example, doing a certain type of a clicking action a lot, that you think is just inefficient and you wish that there was one button, or one checkbox to check all the checkboxes, something like that, you can absolutely request a feature, and if it's possible, then we will change Terra for you. There's also a community forum, so you should definitely check out the community forum whenever you have questions about running specific tools. And of course, you can always contact the support team directly. So this email will go to the frontline support team. And of course, there's also links to our release notes and service notifications in case you're, trying to make sure that you're up to date on how Terra is working. Like if you're trying to figure out whether or not some feature has been updated, then you can check out the release notes. Okay, so that gives you a kind of high-level understanding of what is available on Terra, but not necessarily how a Terra workspace works. So that's what we're going to do now. And this is the part where I kind of half recommend that people follow along with me, although they don't have. At the very end of my session, we are going to find the workspace that we'll be using for the rest of the demonstrations, and we're all going to clone it, and we're all going to spin up our cloud environment that we're going to use for the haplotype faller demonstration at the end of the day. The first thing I'm going to do is I'm going to go to workspaces. And and it's going to take a little bit of time to load because I have access to a lot of workspaces. This is also a good time to ask any questions if anyone has questions so far. A question?
I'm the billing account on many workspaces, so that's what.
Yes.
You're using the wrong account.
Same. It's same for me. This page always takes a long time for me. There. Okay. So what I'm actually going to do is find a very specific workspace, and this is the part that you should follow along with me on. So you can see here there are 4 tabs for all the workspaces that I have access to. This actually is an inclusive list. So this includes all of the public and featured workspaces also, because I have access to all of those, right? Public workspaces are the ones that everybody is a reader user on. We are interested in a particular featured workspace. So I'm just going to type in COVID. And I'm going to go over to public because I don't want this copy that I made whenever. And I'm going to click on this top option right here under public. Also be, yes, it's also one of the featured ones. So the difference between public, featured, and new and interesting is just that they get put into more visible sections. So all of the new and interesting and all the featured workspaces are all public workspaces, but it just so happens featured ones are particularly interesting and well curated, so we put them in our nice featured workspaces section. And some are new and interesting, and we want to draw a particular amount of attention. Today, I'm just going to take a look at this COVID-19 workspace. Okay, so here I am in my COVID-19 workspace. Rather, I'm not in my workspace. I am currently in the public workspace. I'm not going to clone this workspace. We're going to clone the next workspace we look at, but we're going to start by making sure we understand the difference between the public one and the one that would be my clone. So first of all, you'll notice that right here, there's a little icon that says this workspace is read only. But in addition to that, I just can't do things in this workspace the way that I will be able to if I were to clone this workspace. So I can't, for example, start my interactive analysis cloud environment because I'm not a can compute user in this workspace. I can't edit this dashboard. And in general, I don't have the access to either the storage or the compute capabilities of this workspace until I were to clone. And so we'll take a look at what that looks like after we clone our own version of a workspace. But for the purpose of this tour, I'm just going to show you around this public workspace. So we'll go through the tabs one by one. And at this point, please feel free to just raise your hands if you have any question at any point. So here we are in the dashboard of our workspace. The dashboard of a workspace contains all of the information that, or hopefully it is rich enough that it contains all of the information that you need to understand the contents of that workspace. It should ideally contain a summary of whatever metadata is in the data tab. It should give an explanation of what the purpose and use is for the various tools in either the workflows tab or the analyses tab. It should basically just give you all the context you need. That's what this giant markdown space is on the left here. And when we clone our own version, I'll show you how that's an editable space, but it's really just one big markdown field. On the right side of the workspace dashboard is where you'll find your workspace level information for things like the cloud location of all the data. So this demonstration is going to be entirely backed by Google Cloud. There is a version of Terra that runs on Azure. And you can tell which type of workspace you're looking at in this cloud information card. So this is a Google Cloud backed workspace. It also tells you your Google Project ID, which you need for various types of workflows for different types of controlled access. And it also tells you the bucket name. So your Google bucket is associated with every single workspace. Every workspace gets its own Google bucket whenever it's created. So if I were to clone this workspace, what I will get is a completely fresh Google bucket attached to it. And I can look into that Google bucket either by browser, right? So this will show me lots and lots of files in this bucket that will not travel with the clone, right? If I were to clone this workspace, I wouldn't necessarily have the same stuff in my bucket. I would just have a bucket with, it won't be completely empty because the notebooks folder will still be in there, but otherwise it will be a fresh bucket. Also here you will be able to find out who the owners of a workspace are. So if you see a featured workspace, you have a big question about it, one of the first people that you can contact would be the owners of that workspace. The workspaces also have various tags that helps you search for them if you're in the featured workspace section. You can also check on your notifications. So that's what the dashboard is for. It's pretty straightforward. Now moving on to the data tab. This is where things get a little bit more interesting. So the data tab is in many ways the most interesting and powerful part of Terra, because this is where we organize all of our metadata in a way that makes it totally unnecessary for us to ever have to copy files to different locations, because our data tab will organize things in a tabular format with links to these files in their current locations. So you can see here on this table a set of viral isolates that all underwent whole genome sequencing. Actually, I don't remember if I'm able to open IGV. I don't. Not a user on this workspace. I think I can. Yes, wonderful. So, and this is going to be a part of our hands-on demonstration later today and for the rest of the week. You can actually use the integrated genomics viewer inside of Terra like this. So all I have to do is select a row with a genomic file that you would want to view in that way. And then I would click open with, and then I would open it with IGV, and then you can basically start playing around with that and exploring that. And so all of this is tabular data that on the back end is just a TSV. So I can actually download this entire thing. Oh no, yes. So I can download it as a TSV, so everybody knows how it looks. Can I open? Is it possible for me to open a spreadsheet?
Yeah.
Or this will go to the Microsoft Store. No, I don't want to go to the Microsoft Store. That's okay. That's not the most important part of the demonstration. So you guys can do it on your own machines, and I'll just tell you what you'll see since I can't do it on the screen. But I can download this as a TSV, and then I can open it up, and you will see that it's literally just this table And the only constraint that you have if you wanted to write your own TSVs from scratch, and then you can just import them yourself, is that top left corner. That's the part that I wish I could show you, but I don't know what the spreadsheet program is on this machine here. That top left cell is formatted in a very specific way. Right? It says entity. I actually forget what the exact format is now. It's entity colon, and then the name of the table underscore ID. And so long as you write that top left column, that top left cell in that exact format, you'll be able to upload that as a table. And the word that you choose before the underscore ID will be the name of that table. So I could easily create a table called, Anton, right? I would just write entity colon and then put the name of the table that I want, whether it's samples or mice, whatever. And so that's how I can create a table. One of the important things that Terra is capable of doing is linking different tables. So here I have a sample table and a sample set table, and these are linked in a way that is maybe a little too complicated in this workspace for me to try to explain. But in general, having these linked set tables makes it easier to run workflows on different subsets. So I could create a subset myself right now. So let's say I wanted to create a subset like, I can't do that in this workspace because this is not my clone. But I'll show everyone how to do it once we clone our own workspace. So I could choose to modify this by selecting a couple of rows and saying, I want a subset of this data. And then I would get a new entry as a linked table that has just basically these 3 sample IDs in one of the cells. And then in that table, you would be able to select the row for that cohort that you created. And then you can pick and choose which cohorts to run your workflows against in a very kind of efficient, user-friendly manner, right? You don't have to constantly remember, which files do I want to organize and how are they organized on my machine? Terra tries to take care of all of that for you. So that's what the data tables in the data tab are. So that's what we call these. In this case, there's 2 of them. These are the data tables. In addition to the data tables, there's a section for reference data. And these are kind of very commonly used references. So here you can find your HG38s and your B37s, mice genomes, all sorts of popular public references. And then you can point your workflows at those references. In addition to that, there's a section called workspace data. Workspace data is kind of similar to the data that you would find in your data tables, but this is the place where you would park files that you want to use across many different workflows, across many different samples that you don't necessarily want to have. You don't necessarily want to have a column in your data, in one of your data tables, that's just the same file over and over and over for the whole column, right? This is also where you can put less common references. This is where you would put things like interval files, all sorts of what we call workspace level data. And then you can just point to that data in your workflows. And then finally, there's the files section. And this actually is just exposing the Google bucket. So you can see this is exactly the same directory structure as when we opened our Google bucket. So this is how you look into the workspace bucket. And we say in Terra that there are three cloud locations that Terra can be associated with. One is the workspace bucket. And the workspace bucket is created when you create or clone a workspace. When you create a fresh clone of a workspace, you get your own workspace bucket. There is a second location associated with your specific workspace, and we'll be learning about how to create that shortly. That is your interactive analysis cloud environment. So there are two different ways to do analyses in Terra. You can either run workflows in which you hit launch and the workflow does a bunch of stuff and spits out some outputs, and you go to your data tab or you go to your Google bucket to find those outputs. Or you can spin up an interactive analyses environment. And so we have a number of apps that are integrated into Terra. We'll be using Jupyter for these demonstrations, but also you can use RStudio, Galaxy. And so these interactive cloud environments don't exist until you create them, and then you can delete them. And that doesn't harm your workspace in any way. But that's that computational elasticity that we were talking about. You can requisition exactly the right amount of compute for the job that you're trying to accomplish, and then you can just delete it like a disposable computer. So that's what we have to talk about with the data tab. Oh, I said we like to say there are three locations, right? So the first is the workspace bucket. The second is the persistent disk that's attached to your interactive analysis environment. So these are two separate computational environments. And the third place is everywhere else in the cloud. That's the big thing. That's the big selling point with Terra, where all of the cloud locations are accessible to you, assuming that you are actually able to, grant yourself access. So that's what you'll find in your data tab. In your analyses tab is where you will find a list of IPyNB files. So this is where all of the Jupyter notebooks are going to be found. In this particular workspace, there's only one. We're not going to run it right now. But you can absolutely, you can do things like copy the URL to the to the specific notebook, so you can share specific notebooks with people. You can even if you're looking at a read-only workspace, you should be able to click on the notebook and see a read-only preview of it, so that you can see exactly what the contents of it are. Back to yeah. And okay, so in the analysis tab is where you'll find your interactive analysis notebooks. In the workflows tab is where you will find all of the WDL workflows. So just so I understand, by show of hands, how many people have worked with WDL, with WDL, or is today the first time? Just you? Just the young man in the back? Well, I know you know all about WDL. So as Emma was telling everyone, our workflows are all written in a language called workflow description language. And we call it WDL for short. So these workflows are all written in WDL script, and you can see the script itself by clicking on the script tab down here. And if you are just, so this is unfortunately is not an editable field, even if I were to own this workspace. If you want to edit the WDL, you absolutely can, but you have to go through the methods repository. And if anybody is curious about how to do that, I can absolutely demonstrate how to do that as well. But what the reason that the script is exposed here is just so you can take a look at what the workflow is actually doing. So you can see, obviously you can see what packages it uses, but more importantly, you can do things like look for the different command blocks and see what are the outputs, what are the commands actually doing. You can find what the cloud environment is. Where is it? What?
There aren't any tasks.
Oh, there aren't any tasks in this. Okay, yes. So this one is a little bit unusual in that sense. But yeah, this is where you would go to kind of discover what it is that the whittle is actually doing if you are trying to troubleshoot. So when I click on a workflow, we're just going to go from top to bottom. At the top, you'll see the name of the workflow. Then you'll see a drop down to select different versions of the workflow. So in this case, there should be multiple versions, but you can also click on this link to look at the source, it's GitHub. And then here is where you would select the data from your data tab. And this is the part that we'll need to clone our workspace in order to actually be able to modify any of the inputs. But just at a high level, because I don't think we're actually doing any workflow demonstrations soon, you would select your data with your inputs defined by the data table. And this, so if you have this radio button selected to run your workflows with inputs defined by the data table, when you go to select data, you will be given a pop-up that basically just shows you the tables in your data tab. So you can see you can see right here in this drop down. And if you were to clone this, you could actually click on this drop down and you'll see that it has both sample and sample set. And so I would select that root entity type so that I would be choosing either my sample rows from my sample or my sample set table. And then I would click on select data and it would show me that table and I would choose which rows I want from that table. So that's how I select which rows I want. When I want to select which columns are supposed to do what for a particular workflow, I do that under the inputs configuration. And there's a little bit of syntax to learn for how to do this configuration, a very small amount of syntax. We have some great quick start guides for how to do that, but I can also walk people through that later on if they're interested. The thing that we like to show everyone is that you don't have to do it this way. You don't have to run workflows with your inputs defined by the data table. It's just that that's what Terra was designed for. So that's the best practice. But if you would prefer to run your workflows against files that you just, they exist in some bucket. You have access to that bucket. You don't feel like figuring out how to make it so that your Terra workflow is pointing at your data table and your data table is pointing at the Google buckets in the right way. You just want to run your workflows with your inputs defined by file paths. You absolutely can. You would just click on this radio button and then all of these editable attribute fields would just have Google bucket addresses pasted in. So that's how you run workflows. But if you do run them with their inputs defined by the data table, the nice thing about that is then you write back to your data table, right? So I could populate my data tab with the outputs, right? If I were to start running these workflows and if I were to, let's say, name one of my outputs as one of the columns that already exists here, then those outputs would be written right to the table, and then you can do things like either access those files right there, or you can daisy chain your workflows, right? So this is one of those very useful features for pipeline. So hopefully I'm convincing everybody to stop using terminals and start using Terra, because it's a lot more fun. And of course, when you launch a workflow, then you also get a record of all of the workflows that you've launched, and you can take a look inside of any one of these records to do any troubleshooting. So this is a public workspace, so all of these are basically test workflows, so they better all be successful ones. So that's why you see lots and lots of successful workflows. If I want, I can click in to these, and I can learn in a lot more detail what went on with them. Over here, there's something called the job manager that gives you a very detailed view of how your workflow actually went. It gives you things like timing diagrams to tell you how long each step took. It shows you how the parallelization took place in case you're trying to either troubleshoot or optimize your workflows. So with that, I'm going to pause briefly to see if there are any questions, and then we're going to go find the workspace that we're going to use for the demonstrations, and we're going to clone it. So, any questions so far? Yes.
For the reference genome, can you input your own genome reference?
Yes. I imagine that you would do it by adding it as workspace data.
Thank you.
Yeah. Fast. Let's go ahead and.
I have a workspace where I did import my own genome reference. You don't
Well, it'll take so long to get to it. Did you do it? Am I right? Did you do it like
I
this?
brought it in on my own. Yeah, it fits into the workspace.
Into the workspace data? Is it like this as a key value pair?
Yeah.
Nice. Always makes me happy. People use Terra in the way that it's designed. Okay, so what we're gonna do now, I'm trying to think if there's a faster way for me to do this. This is gonna take a hot second. I'm just gonna go. I should have clicked on this and then asked if people had questions.
So now you want everyone to do this also, right?
Okay, this is the part that everyone should be following along with.
What do you think that people are?
Change that. What is it?
I'm not showing up.
Oh, I see. Take the training wheels off, right? Okay. So all we're gonna do right now is we're gonna go to workspaces, and we're gonna find under public workspaces. I'm gonna click public. I'm gonna just type in NOV.
Everyone should do this, right?
Everyone should do this. Just go to your workspaces. Go to your hamburger menu. Click on workspaces. And then just type in NOV and click on public. So everybody should be able to see there is one public workspace called November 2023 Workshop. GATK4, germline pre-processing, variant calling, joint calling. And this is the part we're going to slow down to make sure that everyone has found the workspace, has cloned the workspace, all that stuff. We're all going to be on the same page by the end.
Raise your hand if you need help.
Yes, if you haven't found it, please just raise your hand. I'm going to say one more time, and then I'm going to click into it. So one last time, go to your hamburger menu, click on workspaces until you are in your workspaces section, and then just type in NOV into the search bar. Click on the public tab. Then I'm going to go ahead and click into this workspace. And go ahead and clone the workspace. So I'm going to do it, but if you already know how to do it, do it. Go ahead and clone the workspace. The only thing is everybody has to make a unique name for their workspace because we're all on one billing project together. So that's the constraint. It has to be unique per billing project. So you guys have the same initials, for example, like I have initials that are similar to other people's initials. So I end up just writing some random string or a funny phrase. So what we're going to do is we're going to click clone. Before I do that, I'm just going to go over one more time really quickly some things on the dashboard so that you can see the difference between the public workspace and my clone. So first of all, up here, the name is going to be different, including this beginning part of the name. So this beginning part of the name before the slash, this is actually the billing project on which this public workspace exists. So this will change for everybody because you're all on our little test billing project. And also the name of the workspace is going to change. The owners and all the workspace information is going to change. And most importantly, as I mentioned, you will get your own empty, fresh Google Doc. I'm going to go ahead and do that. I'm going to click clone. I'm going to show people how to do this over and over. Make sure that we've all cloned our workspace because this is the part where we tend to slow down. It's me. Right, and I'm going to go ahead and select so many. So that's what I'm going to do. I'm not going to modify anything else, and we don't need to. I don't know if bucket regionality is important to everyone here, but you can change your bucket location if you need. You can edit the description. You can put a check mark that says that this workspace that you plan to make will have protected data. And you can also add an authorization domain. So this is the security feature that I mentioned earlier. We're not going to do this. We don't need to. But if you wanted, here you could select one of your groups. If you don't have a group, you could create a group under the groups setting, and then you would select that group. And then from then on, anybody that you share that workspace with will have to be a part of the authorization domain in order for them to be able to make clones of your workspace. So we're not going to do any of that, but we are going to clone our workspace. So one more time, you do it by clicking the 3-dot button, click clone. Sure, we'll have a name. Select billing project and click clone. Go. So now we have so many more things we can do. First of all, you can see up here, now it says the billing project that I just used to make this clone, and it has my unique clone name up here. By the way, this is a clickable link right here. So like, if I click on that, it goes to this workspace, and this is a link that you can just share with other people. If I were to share this exact link with any one of you, you would get an error message because you don't have access to this. But if I wanted you to be users on this workspace, I would click share, and then I would add either individuals or groups, so I could add an entire group. If you want to make a workspace public, you can, but this feature isn't exposed. You just have to write to support that you have a workspace that you're interested in making public, or maybe even making it featured, and then we'll start that process for you. Making a workspace public is very simple. If you just want a workspace to be publicly available, it'll be turned on for you within a couple of minutes. But you do have to ask. So if I wanted people to have access to this workspace, then I would want to add them here, and then I can add the various levels of access, right? I have reader, writer, and owner. I have can share and can compute capabilities. So it's fairly granular with what kind of, how you want to share your resources with others. Whether you just want them to be able to see things, whether you want them to be able to actually run computations inside of your workspace. So it's very useful regardless of whether you're using it as a vehicle to share your completed analyses with the greater public, or if you're just trying to use it as a tool for collaboration. It's a great tool for collaboration because you can just add people and be working on all the same stuff together. And of course, now my big giant dashboard is an editable space. So as I mentioned, it's just one giant markdown field. Out of curiosity, by show of hands, are people familiar with using Markdown? Okay, all right. So Markdown is not as rare. So you'll see lots and lots of Markdown in the Jupyter notebooks. So that's how we edit the dashboard if we wish, and yeah, so you can see these are all the things that changed. Now I'm the owner, and of course I also now have a completely fresh Google bucket that I could either access through here. I can also just go to the files section of my data tab, and I can see, right, none of those directories with workflow outputs are here because those don't travel with your clone. Those are individual to a clone. So I made myself a fresh workspace clone, and the only thing it contains in the bucket are the IPyNB files to the notebooks. So you can go here if you want to download the IPyNB files directly, if you feel like playing around with them on your own machine. But we won't be doing that. We'll be running our notebooks directly from within Terra. So that's the last thing that we're going to do. I'm going to pause to make sure that everybody has successfully cloned their workspace. So if you haven't, just raise your hand and someone will come around and help you out. And then the last thing that we're going to do is spin up our cloud environment so that you are all ready for the hands-on demonstration at the end of today. So now you can see this isn't grayed out anymore. Now I can actually spin up my interactive cloud environment. So very briefly, our interactive cloud environments have three parts to their recipe. There's the software, the compute, and the storage. Okay, the application configuration is the software. So this is where we've exposed the different options of Docker containers that you can use. And we're going to stick with the default Docker. That's the one that's got the GATK tools already on it. So go ahead and keep that one. You can, and later on in this workshop, you will use a custom Docker. So to do that, you would go all the way to the bottom here and select custom Docker, and then you would add your address to the Docker file. We're not going to do that at first. We're just going to select the default. I think, if I'm not mistaken, what we are recommended for that notebook is to have 4 CPUs and 100 gigs of persistent disk. So this is where we choose the strength of our of the virtual machine that we're creating, how many CPUs, how much RAM it has. We can also do things like enable GPUs. We can select Spark clusters. We can do all sorts of stuff like that here in the compute profile. And then we select the size of our persistent disk. And we call it a persistent disk because even if you were to delete your cloud environment, you could detach the persistent disk so that you don't lose any intermediary files that you were working on when you decided that your cloud environment just wasn't good enough. So I'm going to click create, and that's basically the end of this demonstration. So this is now going to take between 5 and 10 minutes to be ready. So that's why we're going to all click create now, so that when you get to the actual hands-on demonstration, you're not waiting an extra 10 minutes before you're ready to start running your notebook. So once that is running, you will be able to just open any one of these notebooks in editable mode. So I can't do that right now. I'm creating my cloud environment, and I can see here that my status is still creating. So that takes us through the platform tour. Please let us know if you have any questions or if you have not successfully gotten to this point.